Greetings and welcome to GILFORD'S lectures. So today we are going to be looking at a question that falls under the topic second order non-homogeneous differential equations. The exercise A of our question reads, find the general solution of the differential equation y double prime plus 2y prime plus 5y equals x squared, and B, find the Wronskian of the two functions y1 equals x e to the x and y2 equals e to the negative x. Generally, for you to solve any non-homogeneous differential equation, you first of all have to solve for the homogeneous differential equation of that non-homogeneous differential equation, and you move into getting a particular solution. The sum of the homogeneous and the particular solutions give you the general solution. Let us move into looking at the solution of this non-homogeneous differential equation given to us. So if you set the right hand side of this non-homogeneous differential equation to be equal to 0, you now obtain a homogeneous differential equation. The characteristic equation is given by r squared plus 2r plus 5 equals 0. Solving for the characteristic equation using the quadratic formula, you are going to obtain r to be equal to -1 plus or minus 2i. Essentially, your r1 is equal to -1 plus 2i and your r2 is equal to -1 minus 2i. So the solution to the homogeneous differential equation is given by e to the negative x into a cos 2x plus b sin 2x. Having obtained the solution to the homogeneous differential equation, you now move into getting the particular solution. So the function g of x equals x squared, is effectively the right hand side of the non-homogeneous differential equation. It's a polynomial of degree 2. As you can see, the degree of this polynomial is 2, and it doesn't contain a solution in the homogeneous differential equation if at all your y particular, that is the particular solution, is equal to a0 plus a1x plus a2x squared. So that is the guess or the particular solution. Essentially, the general solution y is equal to the sum of the homogeneous and the particular solutions. Now we are solving the B part of the question. Remember that the B part of the question required us to find the Wronskian of y1, y2. So the Wronskian of y1, y2 is represented as this and mathematically calculated as this. So the Wronskian of any two functions, say y1 and y2, is given by the determinant of y1, y2, y1 prime, y2 prime, as you can see. So remember that your y1 was given by x e to the x and your y2 was given by e to the negative x. Therefore, y1 prime will be equal to x e to the x. Remember that x e to the x is a product of two functions. So when you hold x constant and you differentiate e to the x, you obtain x e to the x. And when you differentiate x and you hold e to the x constant, you obtain e to the x. Similarly, y2 prime will be equal to negative e to the negative x. Therefore, you are going to obtain the Wronskian of y1, y2, that is the Wronskian of y1, y2 to be equal to this determinant. And when you solve that determinant, you are going to obtain the Wronskian of y1, y2 to be equal to negative 2x minus 1. So that marks the end of our question. I believe you loved the video. Please remember to subscribe to GILFORD'S lectures, share to your friends on WhatsApp, Telegram, and other social media platforms.